Hello everyone, welcome to this tutorial by Zebra Code. In this tutorial we're going to look at functions in C++. There are different types of functions in C++ and this makes C++ a great programming language to use. Like many other programming languages, functions perform some individual and some collective tasks. But what are functions? Well, to describe them, a function is a block of code that performs some tasks when it is called upon in a particular program. On its own, a function does not really do anything unless it is invoked. That is, it is called upon to implement the action that it is written or designed to do. There are different ways we define a function because some functions have arguments while some don't have any argument at all. For example, a function can be defined and specified with some parameters that it's expected to take. The first line here is a function with the name add numbers and it's of data type double. It is expected to take int and another int as parameters. This is a function that is designed to take some parameters. However, we can also design a function that will not take any parameters. In that case, we specifically say void when we are declaring it, or we just leave it with the opening and the closing brackets without anything in between them. Function prototyping, definition, and calls. In programs, we actually specify prototyping for a function, then define it, and finally call it. That is obvious in this particular diagram. What we have here is a function with a type of long and the function name, then it's expected to take two arguments and the arguments are integer and double. So we declare the function data type, the name, and the parameters that it is expected to take if it is expecting any parameters. Like I said earlier, if it is not expecting any parameters, we just simply add the opening and the closing brackets. If it is expecting parameters, we add the parameters and the type that it is expecting. Then we also specify the function body. This is where we actually declare the task that the function is expected to perform. The function prototype right here actually tells the compiler some information. That is the data type, which is long here, and the return value, which is also long, and the function name here is the name of the function. The function is called with two arguments here. The first one is of data type int, while the second argument is data type double. The function body, which is here, contains the task that the function is expected to perform. This diagram simply explains the three steps we could use to prototype a function, define the function, and call the function. When we call it, it actually does what it is expected to perform. For example, here again, step 1, long price, which is integer and double. That is, it takes two arguments. This is for function prototyping. Then the second step here is actually the function definition. This is where we write the code that will make the function to perform the task that it is designed to do. Then step 3 is where we actually call the function and it does what it's expected to do. In this case, we pass in some arguments based on what it was specified to do. And once again, here it is expected to take two arguments, and here we are actually passing in two arguments. In C++, we have two types of functions: the built-in functions or the user-defined functions. The built-in functions are also known as predefined functions. These are functions that we sometimes also refer to as library functions. They come with the language pre-built libraries. These functions are built into C++ libraries. There are different types. For example, the math library. The math library has got some pre-built-in functions. Some of them are for calculating the square root. Some of them are for finding the maximum number or minimum number of a group of a number. There are very many, and we will be trying some of them out in a minute. Before you go into the second one, which is the user-defined function, it is always a good idea to try out some of the pre-built functions so that you actually know how they work. It must be mentioned here that the pre-built functions, we don't really have access to the code, so there is a limitation on what we can do with them or how we can modify them. User-defined functions, these are functions that are written by the programmer. You define or you write them yourself, and they do what you write them to do for you. Now that we have looked at the theoretical part of functions in C++, let's do some practical tasks with C++ functions by using both the predefined functions and our own user-defined function. Now, we are going to look at some predefined functions in C++. We will be looking at the CMath library and some already defined functions that it contains. To do that, I have created a file which I named function-1.cpp. I have a folder on my desktop which is called my intro, and I saved the CPP file in that folder. In my CPP file, I have included some header files. The first one is the include IOStream header file, which is common to use, the include string header file, and the include CMath header file. This is the CMath library that we are going to be accessing some functions in. We are using the namespace standard. That is why we have using namespace std here, and we are using the int main function. It is interesting to know that the main function is a predefined function. The main itself is a function in C++. We use it to execute our program, and it is a predefined function. Then return 0 here. This is a standard C++ file. There are so many functions in the CMath library. We will not be able to cover all of them. However, we will use some of them in the course of this video. So I have listed some of them that we will be using. To find out more about them, you can check the official documentation for C++ and check the CMath library for more information. But I have only selected a few of them for us to use in the course of this video. We are going to use the mass function, the min function, the power of function, the square root function, the remainder function, and the fmod function. We will see them in a minute. Let's begin with the mass function. Cout the maximum of 12 and 61 is 12, 61 and line. It's going to return the maximum between these two numbers. So now let's compile the code and run it. I have changed directory to my intro folder, which is on my desktop. Now that I am in that directory, in that folder, I am going to use the G++ compiler. So it will be G++ space -0, the name of the file you want to run it as run1, and now the name of the file that you want to compile. In our case, it is function-1.cpp. This depends on what you named your file. This is the file we are trying to compile now. If you named yours something different, please replace this one with whatever you have named it. Now hit enter. Great, it was compiled successfully. Now I am going to run it. What am I going to run? I'm going to run run1. That's the name of the file that I created myself. You can give it any name, but make sure that is the name of the file that you are going to run now. Run1. Hit enter. Great. The maximum of 12 and 61 is 61. We have successfully used the mass function. We can do more with it than this. See out 32.5 and 26.4. The maximum of 32.5 and 26.4 is mass 32.5, 26.4. End line. Save it. We can also check the maximum of 2 letters. See out. Maximum of A and Z is, because this is a string, put it in quotes. A, comma, Z, end line. Now save the file and let's run it. First of all, let's compile it. Great, it was compiled successfully. Now let's run it. Great. The maximum of 32.5 and 26.4 is 32.5. The maximum of A and Z is Z. That is how you use the mass function in the CMAT library. As we have used the mass function, we can also use the min function, which is to check the minimum of some numbers or letters. So let's do that. See out the minimum of 47 and 98 is 47, 98. So we are using the main function here now. End line. Then one more. See out. The minimum of letters this time around. D and Y is the Y. Now let's run our code to see what the results will be for these 2 lines of code. Again, first compile it. It was compiled successfully. Now let's run it. Great. The minimum of 47 and 98 is 47, and the minimum of day and Y is day. So Y is higher than day. So we have just checked the minimum between letters day and Y. So let's use the function power of. Okay, that is for example 4 raised to the power of 3, and that will be C out. POW is power, that is the function. POW 4, 3. Let's add some string information to it here. 4 raised to the power of 3 is end line. Now let's compile this code and run it. Okay, it was compiled successfully. Now let's run it. Great. 4 raised to the power of 3 is 64. That is how you use the power of function in the CMAT library. You can do one more of that. See out. 8 raised to power of 4 is POW 8, 4 end line. Let's save it, compile it, and run it. Great, it was compiled successfully. Now let's run it. Great. 8 raised to the power of 4 is 4096. Do this as 4. Great. 8 raised to the power of 4 is POW 8, 4. So that is how you use the power of function in the CMount library, which is a standard library in C++. Now let's use the square root function. I'm going to do this with some variables. Let's create 2 variables of type double num, double result. Now let's initialize the first one. Num equals 1024.0, while result will now be equals square root as a square root function, and we are going to pass it the number variable. What we are saying here is result give us the square root of num, and we are going to print out result. Cout, the square root is result. So let's compile our code and run it once again. Compile it. Great. And let's run it. Great. The square root is 32. That is how you use the square root function in the CMount library. Now let's use the remainder function in the CMount library. It returns the remainder of a number in which one number goes into the other. So let's demonstrate that. Cout remainder 18 4. The remainder from 4 into 18 is going to give us the answer. Let's compile it and run it once again. Great, it was compiled successfully. Now let's run it. Great, the remainder from 4 into 18 is 2. What that means is when 4 goes into 18, that will be 16, and 2 will be remaining. So what is remaining is what is printed out on the screen, and it is 2 that is remaining. This is similar to modulo in the arithmetic operation part of C++. We can use modulo to achieve the same result here, but modulo on its own is not actually a function. It is just an arithmetic operator. Okay, now let's use the fmod function. The fmod function also returns the remainder of a number in which one goes into another. It's similar to the remainder function. Let's demonstrate this one as well. Cout the remaining number is fmod 15, 2. End line. Save it. Now let's compile it and run it once again. Great, it was compiled successfully. Now we are going to run it. Correct, the remaining number is 1. So what that means is 2 goes into 15, that will be 14, that's 7 each. 1 will be remaining. Like that, remaining. Okay, correct that, it's remaining. So that is how you use these pre-built functions or built-in functions in C++. We have specifically looked at the CMount library with its built-in functions. We also look at the main function itself, which is a built-in function that we use to execute a program. So in the course of looking at the pre-built functions in CMount, we looked at mass, main, square root, power of, remainder, and F mode. Next, we are going to look at user-defined functions, where we define our own functions. In the last tasks, we used some predefined functions in C++. Now, we are going to use our own defined functions. That is, we will define our functions and use them. To do that, I have created a file which I named function-2.cpp. I saved it in my intro folder, which is on my desktop. Now, let's add some code to it. We will begin by adding some header files. Include iostream, include string, using namespace standard, std for standard, int main. The main function is a built-in function, and it is what we use to execute our program. Great. That's our standard C++ file with some header files added. Now, to use our own functions, there are 3 steps we need to follow. The first one is to do what we call function prototyping. That is a process whereby we make it known to the program that there is a function we are going to use. In this case, we only mention it, we don't actually declare it. That is, for example, I am going to add the add function, and it's going to return a value of data type int. In that case, it will be int add int a int b semicolon. I will comment it out. Function prototyping. Now, below the main method, I'm going to declare the function int add int a int b, and the body of the function, we can just begin here as a return a plus b. All right, now we have done 2 out of the 3 steps. We have done a function prototyping, and here we have actually declared the function. The 3rd step now is for us to actually call that function. I will say cout, and what is the name of our function? Add, and I'm going to pass it 2 parameters, 23, 67. So now with these 3 steps completed, let's compile our program and run it. To do that, open cmd, that's the command prompt, cd to where your folder is. In my case, I did change directory to desktop, and on my desktop I have the my intro folder where I have saved my function-2.cpp. Now I'm going to do g++ space -o run 2. That is the name of the file we are going to run. You can call it anything, but because we are running function2, that's why I call it run2. Now I'll say space function-2.cpp. That is the name of the file we are trying to compile. Hit enter. Great, it was compiled successfully. Now let's run it. Run 2. Hit enter. Great. 23 plus 67 is 90. So we have successfully prototyped a function, we have defined or declared the function, and we have called the function successfully. So those 3 steps, we've done them successfully. We can also declare another function. In this case, I am going to call it add nums. That is again int add nums. I am not passing it any parameters here. It's not going to take any argument, so I just left it with the name and the opening and closing bracket without anything in between them. This is again function prototyping. Now let's declare the function here as a comment So data type int add nums, int a equals 11, int b equals 93, int c equals a plus b, return c. Now we have done the function prototyping, we have declared the function. Let's call it cout add nums. Here we are not passing any argument because in our function prototype it indicates that it's not going to take any argument. So now let's save it, compile it once again and run it. Yes, the compilation was done successfully. Now let's run it. Great, it was run successfully. So the answer is 104. That is, if you add these two numbers together, you will get 104. This is another user-defined function in C++. We defined our own function, we called it, and it does exactly what we have defined it to do. I'm going to prototype another function here. It's going to be of data type int, sub numbers. It's going to do some subtractions for us. We take two integers, integer a, command int b, function prototyping. Now let's declare the function. Here we are going to declare it int a, int b. So it's going to be return a minus b. Now we have declared the function, so let's call it here cout sub numbers. We pass it two parameters here, 96, command 32. So let's compile our program and run it. Great, it was done successfully. Now let's run it. Run 2. Great, 64. That's 96 minus 32 will give us the answer 64. So this is how you define your function and call it. In addition, we also did function prototyping. We can do one more here. Let's quickly do another int subnum. It's not going to take any argument. Function prototyping. Now let's declare the function int subnums. Int a equals 98. Int b equals 53. Return a minus b. So now let's call our function here cout sub nums. It's not taking any argument. Save it. Let's run it. First we need to compile it. Great, it was compiled successfully. Now let's run it. Correct, it shows here it's 45. If we take 53 away from 98, the answer will be 45. That's why we are having 45 here as our result. We can also declare a function that prints out a message. So I'm going to do another function prototyping here. This is just void msg. It's going to print a message for us. Function prototyping. Now let's declare the msg function. These functions can also be in an external file. I will come to that later on, but for now we are just using one file as our function declaration and function call file. Okay, void msg cout. I love C++ functions. Do you? Now let's call our function msg. So let's compile it and run it once again. First of all, clear the screen, compile it. Great, it was compiled successfully. Now let's run it. Super. Here, I love C++ function. Do you? So we have now declared a function which does not take any argument. That is why we use void and mention the name of the function with the opening and closing brackets added to it. Then we call it here, but before calling it, we declared it here. There is something I would like to explain here. When we declare a function, if it is expecting some arguments, we have to pass in the parameters as pertaining to the number of arguments we specified. What does that mean? Here, I will give one example. Int add more, int a, int b, and int c. Function prototyping. What this means is this function takes 3 arguments and we need to pass in 3 parameters. The 3 parameters will correspond to the number of arguments we specified. Now let's define that function. Int add more, a, int b, int c. This function will return a plus b plus c. Now let's call our function add more. It takes 3 arguments, so let's pass in 3 parameters: 33, 50, 99. Now let's compile it. Great. It was compiled successfully. Now let's run it. Great. The answer is 182. That is, by adding these 3 numbers, we get 182. So with this so far, we have done some function prototyping, function declaration, and function call. We can write a function that draws just a line, for example. So let's do that. Let's do the prototyping for that. Function prototyping. Let's declare the line, void line. Okay, now let's call our function. Here I'm going to add a system clear to it. CLS, clear screen. This has nothing to do with our function. I'm just adding this one just to remove some of these numbers that we see on the screen. Now let's compile it. Great. Now we're going to run it. Great. Now you see it has cleared everything off the screen, but the line was drawn across it successfully for us. Whenever we want to add a line, we will just call that line function and it will draw a line for us. If I move this one down below it, this time it's going to clear the screen till this point, then start printing out from here. So we will now see the result for the add more function and the line function. Let's save it and test it, compile it. Great, it was compiled successfully. Now let's run it. Great, it prints 182 on the screen, at the same time a line drawn for us again. We can actually format that line a little bit, pressing the tab twice. Save it. Let's compile and run it. Great, and let's run it. Great. Now you can see we still have 182 printed here, very close to the edge of the screen. The margin is not really obvious, but here we have the line with 2 tabs. So the line is now displaying right towards the middle of the screen. Okay. Sometimes we can also use a mixed and multiple data type for parameters. That is easy. We can add as many parameters as we want in a function. They can also be of different data type. However, when working with multiple parameters, we enter the same number of arguments as they are in the parameters. When calling the function, similarly, the argument must be passed in the same order as declared. This was obvious in our last example, but we can do it differently so that we understand it better. To do that, I am going to prototype a function, call it country code. It's going to take country code as a string for the name of the country, and the code will be an int. So the country code will take 2 arguments, as we will pass in 2 parameters. One will be of type string and the other one will be of type int. So we've just done the function prototyping here. Now let's go and define or declare our function. Defining the country code function. Now void country code string country int code, just like we did the prototyping. Now we see out country uses code for international dialing number. So what we have here is what we are expecting this function to display to us when we pass in the parameters as the arguments. Cout country, that's the name of the country, uses the code, whatever we pass it, for its international dialing number. We should put it there. So now we have done the function prototyping. We have declared the function, defined it. Let's call it. In our program, below the line here, we are going to call it country code. Okay, now let's call our function here country code Nigeria 234. Save it. Now let's run it. Run 2. Great. It says here Nigeria uses 234 for its international dialing number. Again, we can also do something more to that. The line, I can comment this one out now if we don't need the line so much. Comment it out. Great, it was compiled successfully. Now let's run it. Great. Nigeria uses 234 for its international dialing number, which is great. Now let's add 2 more. Country code USA command 1. The USA uses 1 as its international dialing code. 1 more. Country code Germany command 49. And you can also add your own country. If I have failed to mention it, add it as your own exercise. Now let's save it. Let's compile it one more time and run it. Great, that was compiled successfully. And let's run it. Great. Now you can see there it says Nigeria uses 234 for its international dialing number. USA uses 1 for its international dialing number. Germany uses 49 for its international dialing number. There are many other ways we can declare and use functions in C++. You can use the equal sign to set a default parameter value for a function. As we have seen, a function can take a mixed data types and it can also take a single one. Here we can also do one that takes a string, though we have done one before this time. I'm going to do another function prototyping here, void nationality. It will take a string as an argument, string name. Function prototyping. So let's go and define our nationality function, void string name, cout name is an American. Cout name is an American. Now let's call our function, calling our nationality function, Mike Tyson, George W. Bush, nationality Barack Obama. Now let's save it and run it. First, let's compile it. Great, it was compiled successfully. Now let's run it. Great. Here we can see it says here Mike Tyson is an American. George W. Bush is an American. Barack Obama is an American. So it's doing exactly what we declared our function to do. So we can see now in this example that a function can take a string as an argument or as a parameter. The following function takes a name as a parameter and associates it with the nationality when the function is called. Similarly, we can also use the equal sign to set a default parameter value in a function. Here I'm going to do the prototyping for another function. It's a void institution. We take a parameter of string and we will set it as default string. University is a string, we set it as default equals Oxford. Function prototyping. Here institution is our function. It takes a string, and we set that string as university, and we also set it to Oxford as default. Now we have done the function prototyping. Let's actually define the function as we have been doing. Defining the institution function, void institution string university. It could be any name, but I just call it here university. Cout university end line. So now we have defined our function. Let's call it. I'm going to clear the screen again. System CLA, that's clear screen. That is the system related function call. Now let's call our function institution Harvard, institution MIT, institution Cambridge, and now institution without any parameter passed in, we display the default. So let's compile our code and run it. Great, it was compiled successfully. Now let's run it. Great, we have here Harvard, MIT, Cambridge, Oxford. Even though we did not specifically enter Oxford here, it is now taking Oxford as our default parameter. Here you can see we entered some parameters here. We did not pass any parameter to institution this time around, and it is taking the default value, which is Oxford, and passing it straight away. That is why we have here Oxford, even though we did not specifically pass it in as a parameter. It is the default institution we passed there. Now I'm going to define a function which I called login. It's going to confirm a user's first name and last name. It will just do a check there. So to do that, let's set the function prototype void login function prototyping. So login is what we are going to prototype here. Now after the prototyping, let's define it. Defining the login function void login string first name last name. Cout, enter your first name. End line. Cin, first name. Cout, enter your last name. Cin, last name. Now cout your first name space last name. So we have defined our function login. Now we can call login in our program. Before then, all right. Now we can test our code by calling the login function. Let's compile it. Great, it was compiled successfully. Now let's run it. Great. Now it's asking for your first name. So it's zebra code. Enter. Programmer. Yes, you are zebra code programmer. So your first name is zebra code, second name programmer. So here we did a function prototype for login. We defined the login function and we call the login function. Yeah, this is not actually a login system, but this is just an idea, or if you were actually going to confirm the first name and the last name of someone who is logged in into your system. So the login system can be developed more than this. You can add more to it, but for the sake of this video, I am not going to add more to it here. However, there is one last thing we can quickly do to this, because if we want to do a check more than this, we can simply add something to it. We'll say doing some checking. As a comment there. Now if statement, if first name equals last name, we will not let the user go further. Cout first name and last name must be different. See out, enter again your last name. See in, last name. Then see out your first name and last name. So let's compile it. Great, it was compiled successfully. Now let's run it. Enter your first name, Zebra code. Enter your last name. I'm going to enter Zebra code again. I've entered Zebra code again. First name and last name must be different. Enter again your last name. I'll enter this time around YouTube. You are Zebra code YouTube. Great, it's doing exactly what we expected it to do. If your first name and last name are the same, it will not print out this message. It will ask you again for your last name. If the last name and first name are different, it will now print out the first name and last name. There is a little bit of catch here. If you type in Zebra code lowercase and Zebra code uppercase, it's the same thing, but it will let you log in. So I'm not doing any fixing about that. That was just to point it out to you. Otherwise, it's doing exactly what we expected it to do. So in this video, we have looked at predefined functions in C++ using the CMath library and its functions. Then we have also done some user-defined functions by defining our own functions through three processes. The first process was do the function prototyping. The second one was to actually define the function, while the third one was to call it. I hope you learned something from this video. If you have learned something from it, please subscribe to our channel. Thank you for watching.